Hello my dear students. In this video we are going to study probability chapter number 15, class 10th, CBSE syllabus. So you have studied about experimental probabilities of event which are based on the result of actual experiments. We discuss an experiment of tossing coin 1,000 times in which frequency of outcoming were as follow: head 455 times and tail 545 times. Based on this experiment, the empirical probability of a head is 455 divided by 1000 because we have tossed the coin 1000 times, right? So see here, when there are three zeros, we can just from right hand side, some students may be confused how to add points, right? When there are three digits, okay, I'll write here, and divided by 1000 means this, after three digits we have to add point because there are three zeros. That digits will be taken from right to left. So 1 2 3, here I'll add point 0, so 0.455. Okay, similarly the tail value will be 0 point, probability will be 0.545. Okay, so, moving to the probability theoretical approach, let us consider the following situation. Suppose a coin is tossed at random. We know in advance that the coin can only land in one of two possibilities, that is, one is head and one is tail. Other than this, there is no possibility. So, either head up or tail up. We can reasonably assume that each outcome, head or tail, is as likely to occur as the other. We refer this by saying that the outcome head and tail are equal likely. So we don't know, right? It can be head or it can be tail. So outcome can be both, right? Head or tail. We cannot decide that outcome, we cannot assure that outcome will be tail only because we are tossing, we don't know on which side it will fall, right? So for another example for of equally likely outcome, suppose we throw a die once. For us, die will always mean a fair die. What are the possible outcomes? There are 1 to 6, right? So a die, that is a cube, having 6 faces, right? So 1, 2, 3, 4, and backside 5 and 6. 6 phases. So what are the outcomes? Total outcomes 6. So in the 6 outcomes, it can be any value, right? 1, 2, 3, 4, 5, 6. Any phase can fall when we throw a die, roll a die. So we cannot tell, we cannot assure that it will be 6 only or it can be 3 only, right? So, such kind of outcomes are called equally likely outcomes. Remember this. Are the outcomes of every experiment equally likely? Let us see. Suppose that a bag contains 4 red balls and 1 blue ball. So, a bag contains 4 red balls, red color balls, and only one blue ball. And you draw a ball without looking into the bag. Okay, so what are the outcomes? Are the outcomes red ball and a blue ball equally likely? Since there are 4 red balls and only one blue ball, you would agree that you are more likely to get red ball than a blue ball. Obviously the number of red balls are more, right? Red balls are 4 and blue is only 1. So probability of getting the red ball is more than of getting the blue ball, right? So the outcome red and or blue are not equally likely. So we cannot say that it is equally likely. Even though a die is having 6 phases, in the 6 phases, every phase is single value, right? So every phase, if suppose there are 2 phases of 4, then we could say the getting of probability of getting 4 is more likely than getting other digits. But a die contains only 6 phases and every phase is of one value. So we cannot we can say that it is equally likely. But in case of a bag of balls where there are different colors and the number of red color or in any color is more than any other color, then we cannot say that it is equally likely. I hope it's clear. So, however, in this chapter, from now on, we will assume that all experiments have equally likely outcomes. PE, that is empirical probability of an event E, that is P of probability of event E, can be determined by number of trials in which the event happened divided by total number of trials. Okay, so number of in theoretical probability, this is an empirical probability and this is theoretical probability, also called as classical probability of an event E, written as P of E, is defined as P of E, that is event P, probability of event E. Event can be anything. Okay, event means what? Any thing which is happening, like throwing a die, throwing a die or tossing a coin. So event can be anything. So P of E is equals to number of outcomes favorable to the event E divided by number of all the possible outcome of an experiment. I hope it's clear. Let's see the example 1, the first example. When I read out the question and you are trying to solve it, you also read the question once, because reading the question is very important. Find the probability of getting a head when coin is tossed once. Also find the probability of getting the tail. In the experiment of tossing a coin once, the number of possible outcomes is 2. That is head or tail. When you toss a coin is tossed. Okay. This is the front side and back side. Okay, this is head, this is tail. Okay, this is only one coin. I cannot show you the front and back side. Okay, so I'm doing like this. So front side is head, back side is tail. When you toss it, it is equal probability, right? You can either get head or you can either get tail. Okay, no other value. Or you cannot decide that you will get head only or tail only. So let E be an event getting a head. Why event is getting a head? Because they have mentioned getting ahead. Okay, find the probability P of E. Okay, this is P of E, probability of getting an head. Okay, so P of E, that is getting an head probability, number of outcomes of favorable event E. So if it is head and tail, what is the probability of getting the head? That is 1, right? Because once we are tossing a coin, so the probability of getting the head is 1, because one time when we toss we got head. So like that, the number of outcomes favorable to event E getting of head is 1. Therefore P of E, that is P of head, number of outcomes favorable to event E is 1 divided by total number of outcomes 1 and 2, right? 2, total number of outcome is 2 because head and tail. Similarly, if F is the event getting a tail, this is the answer. Okay, 1 by 2. Suppose if they ask you getting a tail, that is also 1 by 2, right? Because same way, like how we are getting H one time, we may get tail also. So probability is half for both of them. 50-50 chances, right? 50 chance, not 100% chance. You cannot say 100% that you'll get head only. You cannot say 100% that you'll get tail only. When cricket match is organized, first they toss a coin, because one player will select head and another player will select tail. So you cannot say that he cannot decide that he'll get head only, so he will select head, right? So there is 50-50 chance that first player will win the toss, or second team will win the toss. So like that, head is having 50% chance, that is half. Tail is having 50% chance, that is half. So remember one more thing, probability, total probability is always 1. If you are getting 1.123, that is wrong answer. Okay, probability should be, total probability should be 1, 0.5, 0.6, like this you can get in the answer, but not 1.2 or 2, like that. So next example, a bag contain red ball, a blue ball, yellow ball, all the balls being of same size. Kritika takes out the ball from the bag without looking into it. What is the probability of she take out the yellow ball, red ball, and blue ball? So bag contains red ball, yellow ball, and all the balls being of the same size. Okay, yellow ball. Kritika takes out ball. Okay, we'll see the solution. See, the total probability is 3, right? So Kritika takes out the ball from the bag without looking into it. Why total probability is 3? Because there are 3 balls. One is red, yellow, and blue. So let Y be the event. The ball taken out is yellow, because they have asked us to find the probability that the ball taken out is yellow, the probability that the ball taken out is red, and the probability that ball taken out is blue. So first we will solve for yellow. See here, let Y be the event of the ball taken out is yellow, B be the event of the ball taken out is blue, and R be the event ball taken out is red. So the number of possible outcome is 3. As I said, there are only 3: red, yellow, and blue. 3 balls. The number of outcomes favorable to the event yellow is 1 by 3, because one ball, one possibility, right? Once we will pick the ball, that is only one possibility that that will be yellow ball. If there were 2 yellow balls, the possibility would be 2. If there were 3 yellow balls, the possibility would be 3. But only one possibility is, because there is only one ball, so possibility of getting the yellow ball is 1. So how many outcomes are there? Total number of outcome is 3, out of which the probability of the event, occurring the event, is 1. So the answer is 1 by 3. Similarly for red ball and blue ball as well. So 1 by 3, 1 by 3, 1 by 3. Okay. P of E plus P of S is equals to 1. In example 1, as I said, when we counted the probability of both head and tail, we got 1. Probability of Y, probability of R, that is yellow, red, and blue ball, is also 1, because add them, 1 by 3 plus 1 by 3 plus 1 by 3, 3 is the LCM. 1, 2, 3. 3 by 3 is 1. So the probability of getting the ball is also 1. The sum of the probabilities of all the elementary event of the experiment is 1. The total probability should be 1, not more than that. Suppose we throw a die once. Okay, next question. We throw a die once. What is the probability of getting the number of greater than 4? What is the probability of getting the number less than or equal to 4? So when we throw a die, we have these probabilities, right? 6 values. Greater than 4 means 5 and 6. Probability is 2, right? 2 by 6. How many values are there? 2 values. Okay. Getting a number less than 4 is 3 values, right? Less than or equal to 4 means 4 values. Greater than or equal to it is, what is the probability of getting a number less than, what is the getting a number greater than 4? That is 2. 2 by 6. See here, probability of getting the value greater than 4 is, number of getting greater than 4 is 2 by 6, because two values are there, 5 and 6, only two values are there, so 2 by 6. 2 ones are 2, 2 threes are 6, 1 by 3. So let f be the event getting the number less than or equal to 4. So less than or equal to 4, how many values are there? 4. Total number of values is 6. 2 twos are 4, 2 threes are 6, 2 by 3. Right? So next is, I hope it is clear to you. So next is, from example 1, we note that P of E plus P of F is half plus half is 1, where the E event getting a head or and F event is getting the tail. So from 1 and 2 we can conclude that it is equals to 1, where E is the event getting the number greater than 4. Okay, second and third example. Okay, and F is the event getting less than 4. Note that getting the number not greater than 4 is same as getting the number less than or equal to 4, vice versa. Okay, if they may twist the question and they can ask you getting a number not greater than 4 means, not greater than 4 means less than 4 or equals to 4. You can get up to 4 but not more than that. So probability of happening an event and not happening and not E. E means event, right? Happening an event. Probability of event and probability of not happening the event is equals to 1. Okay. So we can say that equals to 1, right? So probability of that is happening the event plus probability of not happening the event is equals to 1. So we can say that probability of not happening the event is equals to 1 minus P of E. We have taken this P of E right hand side, so this plus will become minus P of E. Okay, so probability of not happening the event is equals to 1 minus P of E. In general, it is true that for an event E, P of not happening the event is equals to 1 minus P of happening the event, because we know that total probability is 1. So from total probability, if we remove the probability of happening the event, then what is remaining? The probability of not happening the event. I hope it's clear. So event E bar representing not E is called complement of the event. We also say that E and E naught are complementary events. What is the probability of getting the number 8 in a single throw of a die? So we know there are only 6 outcomes. So 0, because we know that it is not possible to get the number 0 when there are only 1 to 6 chances. So 0 by 6, that is equals to 0. 0 by anything is 0. I hope it's clear. The probability, such events are called impossible events because that cannot happen, right? If you have two rooms, room number 1 and room number 2, if you say that I want to go to room number 3, which does not exist, impossible, right? Because there is no room number 3, 1 2 is there, only two rooms are there. You want to say that I want to sit in room number 3, which does not exist. So that events are called as impossible events. See here, probability of the event which is sure is to occur is 1. Such an event is called sure event or certain events. Events such as getting the dice on 6. 6 we will get, right? On a die, we will get the digit 6. So that event can happen, right? So such events are called as certain sure events. See, since every face of the die marked with the number less than 7, it is sure that we will always get a number less than 7. Then it is thrown once. So the number of favorable outcome in the same is the number of possible outcomes. All possible outcome, which is 6. So probability of number getting the less than 7, that is 1 2 3 4 5 6. These are the 6 numbers less than 7. Okay, so less than 7 means this 6 number, what is the probability of happening? 6 by 6, right? That is equals to 1. So see here, 0 is always greater than or equals to less than or equals to P of E, it means probability of event happening is always l- greater than 0 and less than 1. As I said you before, it should be less than 1 but greater than 0. Now there are some examples or questions on cards, okay, club cards, spade cards. So in that, it contain, you know, right, there are 52 cards in a set, okay, which is divided into 4 suits, that is 13 cards each: spade, heart, diamond and club. 13 each. Club and spades are of black color. See, these two are of black color. These two are of black color and these two are of red color. Okay. The card in which suits are ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 2, 3, 2. Kings, queen and jack are called faces card. Face card. How many face card are there in every bundle? There are 3 face cards. That is king, queens and jacks. Okay. One card is drawn from well shuffled deck of 52 cards. Calculate the probability that the card will be an ace, not be an ace. So how many ace are there? 4, right? Because in every set, that is 13, 13, 13, 13. Okay, these are the 4 cards. So each is of 13, thir- each is of 13 digits, 13 cards. Okay, each this set is having 13 cards. Okay, in that one is ace, right, and one is jack, queen and king. So same for all of them. Okay, so out of 52 cards, how many possibilities that we will get an ace? 4 possibility, right? 1, 2, 3, 4, because 4 cards are there. So 4 by 52. 4 ones are 4. 4 ones are 4. 1 is remaining. 4 threes are 12. 1 by 13. Okay. Similarly, second question is not getting, means we have to remove ace card from all of these bundles decks. Okay, so this will become 12, this will become 12, this will become 12 and last will become 12. 12 for the 48, right? Like this also you can solve, or you can just minus the 4 cards from those decks, that is 48 cards. Clear? I hope it's clear. So 12 by 13, that is 48 by 52. 48 by not getting, right? So not getting means we have to remove ace, then all the cards will be there, remaining cards, so we can pick any card. So 48 by 52. 4 ones are 4, 4 twos are 8. 12 divided by 4 twos are 4 ones are 4, 4 threes are 12. 12 by 13. So when we add them, the probability of happening an event minus not happening, no sorry, not not that, note that if, sorry, note that f is nothing but not happening the event, therefore we can calculate that p of f as 1 minus not happening the event, 1 minus happening the event, right? P 1 minus happening the event, right? P of not happening the event is equals to 1 minus happening the event. This formula I had told you before also. So directly we can solve and cross check. 1 minus 1 by 13 is, 13 is the LCM. So 1 cross multiplication, 1 into 13 is 13, minus 1 into 1 is 1. That is 12 by 13. Clear? I hope it's clear. Moving to the next question. See here, two players, Sangeeta and Reshma, play a tennis match. it is known that the probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning the match? So how can we know the probability of Reshma winning the match? By knowing the probability of Sangeeta not winning the match, right? So we can just minus it, 1 minus 0.02, 0.6, 1 minus 0.62. So 1 0.62 minus, right, 0 0. So when we minus 10 minus 2 is 8, 9 minus 6 is 3.0, 0.38. So see here, the probability of Sangeeta winning is P of S is, this is given, and we have the formula, that is probability of Reshma winning means what? Sangeeta not winning, right? So 1 minus Sangeeta winning. So when we remove the value, we get 0.08.